right, so let's go into router 6. Okay, and let's take a look at our topology, not topology, sorry, it's EIGRP, my bad. Our database. Okay, so now extend this. Okay, so we are focusing on router or area 200. Okay, so we got our link IDs, which is our LSA ones. Okay, and we have our summary routes. Okay, now remember in our summary, okay, we have a 12. Actually, I'm sorry, that is a. Did I make that 12? I have no idea. Let's go back and look. We have a 1, 2, 4. Something's going on here. Let's go because we should have 1, 2, 3, 4, 5. Okay, hold on. Let's. Okay, first of all, did I? No. Yeah, I did. Okay, so let's go back over here to router 3. Let's see. The router 1. First of all, let's see that. Okay, so all right. That's a 2 network. Okay, which I should have picked that up, but nonetheless. Okay, so that is correct then. So let's go back over to router 6. We have our 1 and 2, 1, 2, and where are we getting 4 from? Okay, all right. So that means I have that interface enabled, and it shouldn't be. Show IP OSPF interface brief. Okay, yeah. Uh, Yeah. Okay. So remember in the beginning, I had went through all sessions and created OSPF for the interfaces, and there is 0 to check full reachability as a um, just, I mean, really just for that purpose. All right. So interface um, G2. There we are. Okay. So what's going on? So run interface G2. What did I do wrong? Show IP OS. Oh, I didn't put the I didn't put the process. Okay. All right. So that should kill that. All right. And now we go back over to router 1, okay, and take a look at our OSPF database. Which why isn't it there? Wasn't we looking at it from maybe I don't know. Okay. So 3.0, okay, as a summary, that would be correct. Okay. All right, just 3.0, not the 4. Okay, do you see how I'm using the database to see what's happening with my OSPF? Okay, all right. So this is a very, 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 very powerful method. Okay, and people who start off with OSPF don't have that skill yet. They have to develop it. Okay, so use the database as a means of navigating what's being advertised. Okay, so we have the 3 network as a summary route. That's it. Okay, because the only thing coming in, I get this out of the way. The only thing coming into Area 0 from Router 5 perspective as a LSA is going to be the 3.0 network. Now, let's go back over here. Okay? And now, okay, you don't have to, you can use the do command to do this. I just got in the habit of coming out of config T okay, as my career went all has developed. Okay, all right, because I only need to be in config T when I need to be in config T. I don't do and when I'm working, I get out of config T and do show commands at this prompt because if I why be in config T unless I need to be. Okay, all right. If I go under an interface, when I'm done with the interface, I get out of the interface. Okay, if I need to still be in config T, it's just an exit to come out. Okay, to get out of the interface. I'm done. I don't need to be hanging in there doing show commands. Does that make sense? All right. All that does, as far as a habit, is to limit the possibilities of mistakes. Okay, or you you doing config T commands. Okay, or an interface command out of on the wrong interface. That happens constantly. Okay, I don't care if you've been in the field for 30 years. It's very easy to do. Okay, that's why you should never assume. If you go on the interface G1, okay, and you're doing show commands in that under that interface, okay, meaning that you are doing a do command, do show whatever, okay, all right, and didn't get out of it, okay, when you tried to go back to that interface to do more commands, okay, you can easily assume you're still in G1 because you typed in G1, but you forgot that you went into G3. Okay? You forgot. It's just that simple. Okay? All right, your brain's not always focused 100% because you're focused on other things. All right? So I have a habit of getting out of that mode when I don't need to be in that mode. Okay? So that's why you see me constantly doing N. It's literally a habit. Okay? Okay, so let's show IP OSPF. Oh my god. I keep hitting the caps key. I don't know why my finger keeps going to there. Alright, so now, okay, 1.1.1.1, that's correct, because that's learned from router 1. We're looking at summary addresses, by the way. Okay, what's coming into 200. Alright, 1.0 and 2.0. That's it. Okay, that's perfect. All right, now the database is looking the way I want it to look. Okay, and because I'm on router 6, obviously, now you got to understand, okay, from router 5 and 6 perspective, the checksum for each one of these routes are going to be the same. Okay, all right, but the checksum for 6S6 S 6S6 in area 1, it's never going to be the same. Okay, all right. As a matter of fact, we haven't advertised 6S6, okay? But still, at the same time, okay? So now, um, you get my point, okay? Every router inside a particular area should always have the same synchronized database, okay? Now, we're going to go into router 6. First of all, okay, we're going to look at this. And this is our database, all right? We're going to do a couple more, and then we're going to say config T. Router OSPF. I'm sorry, router RIP. Okay, we're just gonna put on version 2, which is pointless. Okay, but we're also gonna say timers, basic. All right, and we're gonna say 5, 10, 20. Okay, all right, and 25. We'll say 15. Nah, we'll say 20, and then we'll say 30. Okay, now this is just to make the replication faster. Okay, so now do show IP interface brief. All right, and then we have to say network. Okay, um, okay, all right. I'm having a brain freeze here, so we're going to do no wrong. You're gonna say, where's the interface? That's why I was on a brain freeze. Okay, so config T, router rip. All right. 2 timers, 5, 10, 20, 30. Okay. I missed one. Oh, I forgot. No, I missed the command. Okay. Now, do show. Alright. And there's a 4 network. So network 192.168.4. Okay. Now, 0 and then 0. That's 0 for my wildcard mask. No, none. I forgot. My bad. Okay. That's it. Now, with RIP, okay, you don't have a choice but to do the classful aspect of um, of the routing protocol when it comes to RIP. So if I typed in 10.1.1.0, it's going to come out with 10.0.0.0. All right, in running config. That's just the way it is. All right, so now, okay, show IP OSPF database. Okay, now we got to go to number 7. Okay, now first of all, config T, interface loopback 0, IP address 777. This is a host address, which is only going to use that one particular address, so that means that's all 255s. Okay, then router rip. God damn that caps. Okay, and then network. Okay, now we have to do the 192.168.4. Alright, first, because that enables RIP on the interface. Okay, this is with any routing protocol actually. Okay, alright. So now the only one you don't have to do that with is BGP. Okay, because and the only way you're going to advertise that interface of BGP is to put it in the network statement. So or I should again, we haven't done BGP, so I'm just making things more complicated. Okay, so now also network. Now watch when I do this. Okay, do show run section rip. Okay, notice how to put it at 7000. Okay, because a 7 in the first octet is a class A network. Okay, that's just what RIP does. All right, so now from router 6 perspective, okay, show IP route, and we're only going to just look at the RIP routes. Okay, all right, I have that now. Okay, so now let's take a look at the database. Show IP OSPF database. Okay, all right, and now let's take a look at router 1. Okay, so 7's not in there. Now you gotta look at this. Okay, let's go back to router 6. Oh my god, I hate that caps. Okay, so 7, okay, can I ping that? Of course, okay? All right, now 7, the 7 network is reachable by router 6, but definitely not router 1 because it's not in the routing table. We already know that. Okay, so why is that happening? Because router 6, okay, knows about router 7 because it is talking OSPF and is talking RIP. And router 6 is learning the 7 network from RIP on its G2 interface. Now, so in order to make that RIP route into an OSPF route, okay, we have to redistribute that RIP route into router OSPF. Now, okay, remember what we're doing here. I'm going to redistribute the RIP route into OSPF. So where do we begin? In OSPF. And I'm going to say redistribute. Okay? And I'm going to say RIP. Okay? That's it. Alright? Now, that's not it. Because here's the thing. Notice it says consider the you know the this one right here. All right, subnets. Consider subnets for redistribution. Now, check this out. I go for an interview for the city of Baltimore. Okay, and during that interview, the guy asked me to take a look at one thing. Okay, all right, and he was redistributing routes into OSPF, but was not using the subnet command. Okay, all right. So it took me 3 seconds to realize you need to add subnets to your redistribution command. Okay, all right, and clear the process. All right, he did that. Bam, it worked. Okay, so obviously, out of all the other interviews, okay, I was his top candidate for that job. Okay, by the way, I actually got the job, and they fired me the week later. All right, for nothing. I mean, keep in mind it's only a week. All right, I hadn't even gotten credentials yet. Okay, that's just the way the contract world is, man. All right, you have no idea what's going on in the background. It is what it is, especially in the tri-state area, Baltimore, Maryland, D.C., and Virginia. Okay, anybody who lives in this tri-state area is laughing at what I'm saying because they know how it is. All right, so we're gonna say subnets. Okay. Actually, we're going to just say, no. We'll just say something. Let's just be done with it. Because this is not a redistribution lesson, okay? So now, okay. All right. Then we're going to take a look at not our routing table, our database. Our database is what tells the truth. 7's there. Okay? All right. It's even saying the advertised router is router 6. Okay, so now let's take a look at the routing table to find out how the data plane is dealing with this. Okay, it says send it to 2.5 as the next hop. So let's try it again. Maybe it wasn't converged yet. Or let's go on the router 7. Okay, and let's do our very first debug command. Now, debugs. Should you ever do debugs commands in production? Hell no. Okay. Do I do them in production? Yeah. Okay. All right. So, again, there is a high level of making a mistake. Okay. And if you do a debug command and the debugs, because what you're doing is saying, look, debug, meaning that whatever's happening in the background, okay, I need you to bring that to the console, okay, and show me what's going on. Now, here's the thing. If that output of your debug command, because it could be a lot, depending on what debug command you're doing, all right, if that information is flooded, that means it's going to flood your console output with information. Okay? And now here's the thing. All right? If it's enough information where you can't even type in a character because your console output is so busy pushing out information to the screen, okay, as output, okay, you're stuck. The only way, even if someone consoles into that device, okay, they're going to get that output. And the only way to stop it, okay, all right, is for you to reboot that device. So don't do debug commands unless you are really good with them, okay, all right. So I do them all the time, but you know, I'm very specific, and you know, it's a risk. Don't get me wrong. It is a high risk of me typing in the wrong command or pasting in something that I shouldn't be pasting in. Um, you know, thinking it's in the clipboard, or doing not forgetting to actually be more specific with the debug command with an access list. Yeah, okay. And hey, I take that risk all the time. I do it. All right. So if something happens, okay, only thing I could do is call my boss up and say, "Yo, I fucked up." Okay, and deal with the consequences. Okay, because I know better from that perspective. All right, and it's just like anything in life. Okay, I know I shouldn't be doing this, but I'm doing it now. And when I get caught, don't be crying. Okay, you see what I'm saying? So yeah, don't do debugs. Okay, so I'm going to say now we got to understand another thing too. When I say debug, okay. All right. Actually, let's go up here and say, let's do a question mark. Let's find debug here. Debug function. See also undebug. Well, that's the first. I've never seen that before. All right. So let's say debug. Okay. And I'm gonna say IP. Okay. And I'm going to say right here, packet. Okay. All right. Now here's the thing. If I hit this, okay, we're already getting messages. Okay, already. Okay, and the 224.0.0.5.9, okay, we are getting multicast addresses. All right, and there's a lot of information, and this is nothing compared, okay, to something in production. Okay, this thing will flow. Let me tell you this: you do a debug IP packet on any device, okay, or and I mean router, switch, especially a core switch, you're never getting access to that console again until you reboot physically. Pull the cable and put it and the power cable and put it back in. The output would be astronomical. Okay, all right. Now, keep in mind that we're getting this just from one router, which is router 6. Okay, but at the same time, I'm not really looking at what I'm looking at. So I'm going to actually uh, undebug. All. There we go. Okay, so that stops it. So I'm going to create an access list, okay, to be more specific. Access list is something we're covering next, probably next video. All right, so don't worry about the syntax, okay, but I'm going to create one. Access list, okay. We're going to just do a standard, which that is determined by the number that we use. Okay, I'm just going to say 1. Okay, and standard IP addresses, we're only going to match on the source. Okay, so we're going to say, and how are we going to match this? Okay, because we're doing IP packets. Okay, so the thing is, source IP, destination IP, source MAC, destination MAC. As we are creating a flow of traffic coming from um, this router 1 to router 7, we got to think about what's happening here. All right. So first of all, okay, let's go into router 1, show IP route. All right, and it's 7, and the next hop is dot .5. Okay, but 2.5. Okay, we need to figure out. Oh, here we go. It's G20. So remember, it's in the routing table. The data plane is going to send this via, okay, because the control plane says is G2. Make sense? Because the control plane puts the actual information in the database, right? I mean, in the routing table. Okay, so the data plane is going to forward the packet via G2. All right. Now that means, okay, um, because the control plane said it's going to be G2. Now, 2.5 is my next hop. That's not directly connected. Okay? Alright? So as I build the packet from a layer 2 perspective, I'm sorry, from a layer 3 perspective, what is going to be my source IP address? It's always going to be the IP address of the egress interface. Okay, by default, unless I change it from whatever parameters and manipulating the control plane, okay, or manipulating the next hop, okay, meaning that if the next hop was 1.2, okay, then my egress interface will be 1.1, okay. So I have to go in here, show IP route, okay, and I need to figure. Oh, I'm sorry, show IP interface brief, okay, and this will be the source IP address G2, as I'm using that in my routing table to access my data for that route. That's going to be my source IP address. Okay, make sense? All right. So now in my access list, I'm going to go back over here and say permit. Okay, 192.168.2.1. Okay. All right, and then done. Okay. Now I'm gonna say debug. Damn it. Debug IP packet and then call that access list. Now, let's see what happens. Okay, we're going to clear this off. When I send a ping, nothing. Not at all. Okay, so let's do this. Okay, let's say undebug all, and let's say I'm going to create an access list, but it's, oh, sorry, access lists. Always use the contact help. I'm going to say 100 because it's an extended access list, which means I can match on a source and a destination. Okay, and we're talking about this now because our next section is going to be access list. So this will help. All right, and I'm going to permit IP from any source, okay, to 7.7.7.7, okay, and my wildcard is going to be 0.0.0.0. Done. Debug IP packet, call 100. Let's see if that works. Okay, so now we got something interesting going on. We're not getting any output. Now let's um let's look at this, because if we just do an IP packet, we definitely got output, okay? So that means, okay, router 1, all right, let's take a look at that. Let's do the same thing. Debug IP packet, okay? Well, that's interesting, okay? Oh, there it goes. Okay, so we are getting stuff. So that that's really not that bad. But at the same time, I still want to be specific. So, all right. So now, la 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 la. So config T. All right. We'll just say access list. Okay. Um. Let's do one. Okay. And we're gonna say permit. I always forget the permit thing or the deny. That's why question mark is my favorite thing. Which will become yours as well. So, um, okay. We're not gonna say any. We'll say host. Don't even have to say host. We'll just say um. Well, host. That means I don't have to do a wildcard, I believe. So 192.168.2.1. Okay. So debug IP packet. Calling that. Okay. So ping 7.7.7.7. Okay, so there is our output. Okay, now we're gonna first of all we're gonna first of all we're gonna do this. No service. Oh my God, timestamps. Okay, what that does is that turns off the timestamps in my logging. So let's do this again. Okay, yeah, it looks a lot better, doesn't it? Okay. Oh, you know what? I'm getting way too much information. Let's do this. Let's only do it once because I'm doing 5 pings. Repeat 1. Okay, so there we go. We're gonna take this and we're gonna copy in here in the notepad. Okay, so first of all, so we're even getting the multicast traffic that's being sent out because I'm matching this only the source of this IP address. Okay, so now, so source IP address 192.168.2.1, okay, destined to here, okay, is going out G2 and it is routed by the fib. The fib is created by the control plane, okay, which is the routing information base. The fib copies that information into the routing table, okay. I'm sorry. I mean, the rib is the routing table. That information is copied into the routing table, okay. The fib is your forwarding information base, meaning that it's going to get that information, okay, from the routing table and build its own fib table, okay. So you get the rib, which is the routing information base, which is the routing table, okay, and you get the fib, which is the forwarding information base, okay. So now the next line, source, okay. The next step is from 192.168.2.1 destined to here, GO, Okay, the length of the packet is this. Okay, and here. Okay, now I don't know if that's the length of the raw data or the entire packet. Okay, don't really care. I okay, because when we look down here, um, now if I did care, all right, I would take a packet tracer, okay, and look at all the stuff, okay, including the layer 3, layer 4, layer 5, okay, layer, the layer 2 and layer 3 packets, find out what size they are, okay, and if it's more than 100, then I know that the raw data is 100, and then whatever overhead on top of that 100 is going to increase the size of the packet. Okay, the entire packet. Does that make sense? That's why I don't really care. All right, if I really did care, I would go deeper and look into packet tracer. All right, so uh, okay, this one doesn't matter because it's multicast. All right, so this was sent. Okay, so now we got to take a look and see what the hell's going on. All right, so undebug all. From the perspective of a debug IP packet information, router 1 forward the traffic out. Okay? So, show IP route. Ping. 7.7.7.7. Wow, it can't do that either. Okay? Let's take a look at 6. Ping. 7.7.7.7. Okay. Alright. So, this is our problem now. Not even router 5 can get to 7.7. So let's go take a look at the routing table. Okay, this is unexpected. Okay, but we love unexpected stuff in our labs. Okay, so let's take a look at here. Learn from 3.2. What? 7.7.7 is via 3.2 G1. Okay. 3.2 is router 6. Okay, so yeah, we're good. I'm thinking, I was looking at it wrong. Okay, so G1. Let's figure out what's going on because the packet is not even leaving router. Okay, let's do a debug. Okay, so not much information. So ping 7.7.7.7 repeat 1. All right, and oh my god, let's turn the times. I hate the timestamp, so I'm trying to debug stuff. Okay, we don't need this because it's multicast. We don't need this. Okay, so it's sent. It's sending and it's sent out. And it went out G1. Okay, so what is router 6 doing with it? That's weird. Okay, so if I'm sending it to router 6, router 6 doesn't forward it. So let's think about that. Okay? Alright, this is an OSPF route. We send that over to router 6. Okay, router 6. sends it to 4.2. Our return traffic. Oh, okay. I know what's going on. Okay. This is all we have in our routing table. Okay. Remember that the only thing that changes on a hop by hop basis, going from router 1 to 5 to 6 to 7, is the MAC address. Okay, MAC addresses change hop by hop. But in order to have the communication between one router and another, the source and destination IP address does not change until it gets to the destination, and then we change it as we are sending the replies back via saying that now I'm the source, router 7, and router 1 is the destination. So my return traffic, that's the problem because I don't have a route in my return table for 2.0. Alright? Why? Because router 7 is RIP. So I need to go back over to router 6, okay, and redistribute OSPF into RIP. You see? Alright, I have to do bidirectional redistribution because unless, okay, here's the thing. I could also do this. I don't have to do that at all. I can actually just say for router 7, IP route 192.168.2.0, okay? Alright, 255.255.255.0. Alright, and we're going to send this to 192.168.4.1, okay? And we're going to send that there. Okay, do show IP route. And now I have a route for 2.0. Okay, so now I'll go back over to here to router 1. And I am successful. Okay, because router 7 knows how to get back. Alright, that's all I had to do. Okay, now, the reason why we do it that way as far as the static route, because think about why you're doing this. Yeah, okay, well, let's create a scenario. You have an OSPF domain, okay? All right, you are company Kyle, okay, and you have obtained um, Kmart, okay, and Kmart uses RIP, okay. So as a temporary solution, before I migrate Kmart's network into my OSPF domain within an area, temporarily to get everybody connected, I'm going to redistribute their routes from RIP into OSPF. Okay? Alright? So I can reach their routes. However, I don't want to propagate my routes into their domain. Okay? I just want them to be able to get to router 1 from the perspective, because that's where my server farm is. Let's look at it from that perspective. As far as the other routes, I don't need them to know they're network engineers just yet. They don't need to be knowing my routes, and they don't need full access to my network just yet. Okay? Alright, as we redesign their network into OSPF, that's when we decide what routes they need to get to. But for right now, they only need to access router 1 because that's where our server farm sits off of, okay, as resources. 1.1.1.1 is our access into the server farm. Does that make sense? Okay? So this is a real design purpose. So now I'm only going to send a default route for the route to get to the server farm. Okay? Now, they remember asking the engineers, what's the route for this? What's the route for this? And they'll say, that's at this point, no information will be giving out until you guys are merged into our network. They'll be mad, but it's not their decision anymore. They're no longer Kmart. They are Kyle slash Kmart, okay, and now it's my network, not theirs. Okay? Make sense? All right? Yeah, things like this happens all the time, especially if you have like a subdivision. Let's say you want to uh, creating a software. Okay, so you decide you can go out there and buy Microsoft. Okay, so now Microsoft's network is now a temporary attachment to your network. Okay, they use different routers, so you got to redistribute. But at the same time, they only need resources that are sitting on your servers. They don't need to know your entire topology. Okay, all right, makes sense. Okay, now so we got reachability all the way back. Now, but here's the thing. Let's take a look at router 5. Oh my God. Okay. Okay, are we... Yes, we were. Now, look at our Type 5 LSAs. At least in the database, okay, at least it tells you it's a Type 5. Okay, do not do not get me started on why that information, okay, that is there in the OSPF database could not be put in for the router IDs and network IDs and summary addresses. Don't get me started. Okay, it's sometimes when you look at things that why how is it designed, it's like, guys, this could have been updated in any iOS upgrade in the past decade, 2 decades, 3 decades. Why is this not done yet? Okay, so it's that's just the way it is. But notice our database now. Okay, so now let's go back and realize that this is a Type 5 LSA. Now here's the thing. Okay, here's the thing. Let's take a look at router 1 now. Okay, we have 4 area 200. We got our router IDs, our summary IDs. Okay, we don't have any network IDs because it's, you know, we're pulling anything that's in area 200 from the summary addresses. Okay, and um, we have our 7.7 and our 4 network. Okay, all right. So there's a thing called LSA Type 4s. And this is kind of weird because it's the fact that it's just weird. Okay, um, the way it works. Okay, Type 4 LSAs are from ASRBRs. That means this is an ASBR, where this is an area border router, ABR. This ASBR is an autonomous system border router. And you got to understand, you might have 2 areas, but area 0 and area 200 is part of your single autonomous system. Okay? All right? So in your autonomous system, you can have multiple areas. All right? Now, where are we ever going to see type 4s? Okay? All right? Type 4s are from ASBR as a identical in structure of a type LSA, a type 3 LSA, and sent when crossing the ASBR. Okay, so that means if it's sent while it's crossing the ASBR, I don't see it here. Okay, that's okay. All right. All we know on router 5, okay, we have external routes. All I know on router 1, oh my god, that cap gets me every time, guys. For years, I mean decades, that cap is always in my way. And you know it's nobody's fault except my finger memory. I saw database. Okay? I also have type 5 LSAs. Okay? So that means even the type 5, the external routes, will go from an outside area into area zero's backbone. Okay? Which is amazing. So show IP route. Okay? So now, okay, that route is here, but in our database, it's also there. So, how do we make sure our convergence is complete? Through our database. We can look at the router table all we want, but if we really want to know the truth, our OSPF database does the trick. Okay? So, now, we have done external routes. Okay? So now, an external LSA which is originated by the ASBR and describes external networks. Okay? Alright? We're not going to talk about this. Okay? That's for a later video and it's not part of this discussion. Okay? Alright? Because all a NSSA is, we call it a not so stubby area because we still have to talk about stub routes. Okay? And stub routes is a whole nother topic. And it's we got to, first of all, I got to create the curriculum for that. Okay? For the stub areas. Alright? Because apparently I missed it. It needs to go in this section. Okay? So I gotta do that, and maybe we'll talk about that next, or maybe we'll just leave it on the table for another discussion later on. Okay, because be honest, remember these routing protocols as I am going over them, this is just the beginning introductions to them. And if I spent all this time, okay, to show you OSPF as an introduction, okay, that should tell you how deeper it can go. Okay, it is a complicated protocol. Okay, and yes, I make it seem easy. Okay, all right. I should have known router 7 needed a route to router 1, but then again, look how long it took me to find it. Okay, all right. That's guys. That's skill. Okay, that is the byproduct of doing this over a period of time, over and over and over and over. Okay, it becomes a skill. All right, it becomes a part of you. All right. So when you're doing this at the beginning, you're nowhere near going to have my speed, my intellect, and my knowledge of that protocol because I'm gonna tell you, OSPF and CCNP days kicked my ass. Okay, I literally tried to get my CCNP in 6 months, and I swear to God, it took me a year because OSPF was no joke. It's not just a matter of having the skill set of OSPF; it's the moving parts, guys. It's so much. Okay, all right, and I'm telling you, OSPF, boy, when I, when I would actually go to the college that I was going to at that moment, which was just an ITT college, okay, until I decided that I was going to do networking, and then ITT was irrelevant. But large classroom, okay, three full size whiteboard, 8 feet tall and probably 8 feet wide, okay, and I had three of them, and I'm telling you, when I would go and go over OSPF, okay, I would come in first thing in the morning as soon as the doors open, and I would start on the left board, on the left side of the room where the windows were, and by the time I finished putting my notes on that board, I had filled up all three boards, okay, on the right, ending at the right side of the board, and man, everything is up there. Okay, OSPF states, okay, for our neighbor relationships, okay, what needs to be done in order for a neighbor to come up, our area, what area zero means, okay, all the LSA types, yeah, okay, and I'm doing this every day. That's the only way I can memorize it. Screw the the flashcards, okay, all right. This had to be in my vision from board to board every day until it really started clicking, man. When I say OSPF kicked my ass, y'all, it kicked my ass. It put me down on the ground so many times. Okay? So when it happens to you, I've already not warned you, but I'm telling you what's coming. Okay? Alright? Now, if it's a breeze for you, dude, you're way beyond my intellectual skill set. That's all I'm gonna say. So, as always, be strong, be determined, be Cisco.